Very good morning. Welcome you to the NPTEL course on Advanced Distribution System Analysis and Operation. And we'll be talking about more details on transmission system and how it is different to distribution systems. In our previous lecture, we talked about the distribution system specific to challenges associated with active distribution system of India in specific. And today we'll try to see more in detail about power transmission and distribution network, what are the similarities and what are the dissimilarities or differences between these two different type of networks. Now, what we've done in our previous lecture, we focused on actually transmission and distribution levels. As you could see, based on the voltages, that to 400 kV, 220 kV, 132 kV, specific to high voltage operation of any grid is normally known as my transmission system. And then we do have a little bit low voltage, that is 66 kV, 33 kV and 22 kV are considered to be sub-transmission level. So, these two zones of voltage operation starting from actually 22 kV to 66 kV considered to be sub-transmission level, and then 132 to 400 kV considered to be my transmission level. So, this zone of operation is my transmission system. However, below which 11 kV till 440 volts will be known as a distribution system. Now, let us try to understand what exactly happens in case of transmission network. Electric power transmission is the bulk movement of electrical energy from an electricity generating site to a distribution network. So, as you know, we have transmission system, generation, transmission system, distribution system and consumer. So, the transmission system, the role is to evacuate the energy from the generating system and put it in the distribution system. Okay? And there are different type of transmission systems. Majorly they are AC transmission lines, but some of the portions are actually HVDC. And in India, we do have both AC and HVDC system, but majority of the transmission system are AC in this country. Now, the voltage level, as I discussed already, they are varying from actually 132 kV to 400 kV and as high as 765 kV, which is in operation today in India, and HVDC, which is from actually 100 kV to 800 kV plus or minus, sub-transmission, which is 22 kV, 33 kV and 66 kV. And moving towards the transmission network equipment, we will be having substations, we will be having actually power transformers, and then we will be having transmission lines. So, when you talk about substation, it is the crucial junction in the power grid where electricity is transformed to high voltages for long distance transmission and then step down for local distribution. Now, in case of a power transformer, which is used to step up, increase or step down, decrease voltage level, and they operate with very extremely high voltage operations. Now, transmission lines, which is responsible to carry high voltage electricity over long distances. Now, we do have protecting devices to protect an electrical circuit from damage caused by overcurrent, circuit breakers, relays and isolators. Now, reactive power support, which is quite important. So, power flow control, stability and power transfer, voltage enhancement is possible through capacitor banks, reactors and FAC devices. We do have HVDC converters. So, AC-DC conversion for HVDC lines is equally important for carrying out HVDC transmission. Now, let us focus a little bit on HVDC transmission line and their practical arrangements. As you could see, both the corners, which is going to be AC, that is my grid 1, the other terminal is also AC at grid 2. But in between, we convert AC to DC, then transmit over 1000 miles, and then we convert from DC to AC and then supply to the grid. So, what exactly happens? Both the terminals are fixed at AC, two different grids or two different zones are being connected through a HVDC transmission systems through huge rectifier as well as a inverter mechanism at both the terminals, and whereas the transmission between two zones or two areas or two buses are possible through DC transmission with high voltage is known as HVDC system. It claims that HVDC system is lower cost for long lines such as close to 1,000 kilometers and for overhead and 30 miles for underground or submarine lines. So it is normally not very common for short distances, but if it is underground or submarine applications, then up to 50 kilometers is fine, which is close to 30 miles, and 1,000 kilometers, that is 600 miles for normal surfaces. Now, HVDC is a power transmission technology that uses direct current DC for bulk power transmission over long distances, offering advantages like reduced losses and the ability to connect asynchronous system, unlike the more common alternating current AC systems. Now, what are the advantages? The benefits, there are a lot of benefits for HVDC system, which is a lower cost than AC for long distances, and controlled power flow, which is possible, limitation of short circuit currents, high speed electronic clearance of temporary faults, transmission at reduced voltages when line insulation is damaged. HVDC transmission results in lower losses compared to AC, especially over long distances. Though there are a bit of losses in rectifying and inverting it, but nevertheless there is no reactive power in the whole transmission system, and hence this experiences less loss compared to AC systems. Now, this is the transmission infrastructure of India, which is very, very huge. As you could see that, what are the available data till 2022 and what has been proposed till 2027, it is huge. I mean, all of you please concentrate. The transmission line is almost close to actually 580,000, circuit kilometers, which is very, very huge. And similarly, the substations, we do have almost close to 1,781,000 substations. And then we have actually HVDC network, which is close to capacity of actually 45,000 megawatt capacity as on today in this country. Now, let us focus on distribution system. As I told earlier, so this zone is my transmission system, and now we will focus on the distribution system, which is between the transmission system and the consumer. Electric power distribution is the final stage in the delivery of electric power, carrying electricity from the transmission system to individual consumers. Now, there are different type of lines: single phase, two phase and three phase. The frequency of operation could vary from 50 hertz to 60 hertz across the world, but currently India is operating at 50 hertz, North America is operating with 60 hertz, and so on and so forth. The voltage levels are mainly of 11 kV, 6.6 kV and 3.3 kV, and secondary distribution is 400 volt / 230 volt. So, this we have focused to Indian standards. However, those values actually slightly differ when we move to the European Union zones as well as South America distribution system. They are slightly different compared to Indian system, but as a whole the philosophy remains same, excluding the magnitude part. Now, there are very important distribution network equipment. One is called as distribution substations, similar to transmission substations. Now, we will focus on distribution substations, and the role of a distribution substation is to step down more or less a high voltage to a medium voltage, and there are different components within which are transformers, circuit breakers, relays and bus bars. There are different type of actually substations, primary substations, secondary substations, and so on and so forth. Now, one important concept in distribution system is about distribution transformers. Further step down voltage to 415 or 230, or sometime actually for the consumer requirement, and the step down voltage is possible through a distribution transformer. You might have seen distribution transformers are either located at the end of the street or sometime it is mounted on the pole itself, installed on poles, underground vaults or substations. Now, distribution equipments also covers up feeders which carry electricity from substation to local areas at medium voltage 11 kV. They are overhead feeders, underground feeders, whereas in distributors supply power from distribution transformers to end consumers at 415 volt or 230 volt single phase. Service means the final connection from distributor to consumer premises. They are of two different types, single phase and three phase. Single phase 230 volts for homes and small shops. However, for three phase supply is for industrial as well as commercial buildings. Smart meter and energy meter, as you all might have seen, there is an energy meter connected at your residences or commercial buildings that perhaps account the energy being consumed. So it measures the electricity consumption and other monitor grid performances. There are two different type of energy meter. One is so-called analog energy meter, very old meters, older technology, and currently we all are using smart meters which enables real-time monitoring and remote billing. Capacitor banks and voltage regulators improve power factor and voltage stability installed at distribution substations and along feeder lines. Because sometimes, as I told you, the voltage drop actually when the cable moves hundred of meters away, and that voltage drop can be compensated by injecting reactive power through a capacitor bank. Let us focus on distribution network infrastructure in India. As you could see that, the substation count, which is close to 52,000 expected in 2030, but even 2022 we had close to 40,000, substations of capacity 66 kV, and then the number is close to 40,000 and the capacity is going to be 482,000 kilovolt. Feeders, the numbers are actually again close to 36,000 and the feeder length is close to 600,000 circuit kilometers, very, very huge. And the 11 kV feeders numbers will be close to 230,000 and feeder length is close to actually 50 lakh circuit kilometers of actually feeder of 11 kV. Now moving to distribution transformers, it is again huge, close to 1.5 crores of actually distribution transformers, and again the LT feeder circuit length, if you calculate, which is going to be 80 lakh circuit kilometers of LT feeders, and 60,000 capacitor banks, and consumers finally 33 crores, which is very, very huge. Or to me, 33 crores of consumers currently operational, and that is close to 33 into 10 to power 7, am I right? Or we can say 330 million consumers, all right, for better understanding. And we expect it to go as high as actually 500 million consumers or 50 crore consumers in the year 2030. Now, a bit of comparison between transmission line and distribution line. As you could see, this is transmission and this is going to be distribution. Voltage levels first, what are the voltage levels for transmission line? 33, 66, 132, 220, 400, 765 kV, and for HVDC it is plus or minus 800 kV. Now in case of distribution line, it is always less than or equal to 11 kV. Once again I reiterate, those international students, please concentrate that these data are specific to Indian distribution transmission systems. However, you can refer to your own distribution and transmission systems to understand more about the magnitudes and values for your own distribution and transmission network where you belong to. Now, the current carrying capacity for transmission line, it is designed to carry a large amount of current, therefore, it has a large current carrying capacity. However, in case of distribution system, it has a very, very low current carrying capacity. Transmission system is balanced and distribution system is always unbalanced. The conductor size, the diameter of the conductor used in transmission line is large. However, the diameter of distribution line is relatively smaller. The line length, which is long in case of transmission, short in case of distribution lines. It is 3-phase in case of transmission. It is 3-phase, 2-phase and single phase in case of distribution lines. About the ground clearance, we need high ground clearance because it operates with very high voltage. However, distribution lines are clear from the ground but not as high as transmission systems. Type of lines, we have a long transmission, medium transmission and short transmission. And in case of distribution, we popularly known as radial systems, ring mains, and interconnected distribution systems. The line support large steel towers are used to carry those transmission conductors. However, in case of distribution, we use wooden poles, rail poles, RCC poles, and many other varieties of poles for carrying distribution systems or distribution lines. Now, how do we maintain? The transmission lines are maintained needs to be operated more actively than distribution lines, requires both automatic and manual treatments, and distribution lines requires less maintenance, and they are mostly managed by manual approach. Now, one more important parameter about the resistance and reactances of transmission lines and distribution lines. Once again, I request all the participants to take the notes and note it down, because this is very, very important. You must have heard about a ratio between R upon X or X upon R. Okay, and based on those ratios, we integrate, which line or which cable belongs to transmission, or which line or which cable belongs to distribution. Now, if you see, in case of your transmission lines, the X by R ratio is very, very high. But in case of distribution system, the X by R ratio is very, very low. So, what is the X by R ratio? We'll start from bottom to top approach. When you move to 765 kV, the X by R ratio is close to 30. Please remember, these are all very, very important parameters. I mean, there's no guarantee that these values are exactly correct, but they are approximate values and very, very important parameters. One need to note it down. And in case of 345, it is close to 20. In case of 150, it is close to 10. And in case of 22 kV, it is close to 2. Okay, that is how actually we remember. So, we can remember 20 kV 2, 150 kV 10, 350 kV 20, 765 kV 30. So, that means the X by R ratio is keep on increasing as voltage rises. Okay? And as you know, the transmission system do carry high voltage networks, and that is why the X by R ratio for transmission system is higher, and that is what you have seen in the table, that for high voltage the X by R ratio is going to be high. And their values are quite important, because many times you will be asked, what is the X by R ratio for 11 kV? So, you must say at least it is below 2. Okay? That is what the trick is all about. Now, losses of transmission versus distribution lines. So, that is again interesting. First of all, try to understand what are the values of resistance in case of voltage level. So, again, when the voltage is from 22 kV to 150 to 350 to 765, you could see that the resistance is keep on reducing. When the resistance is keep on reducing, that means the losses also keep on reducing. So, what does it mean? For high voltage system, the losses are extremely lower. So, what about the transmission system losses? Is it high or low? Transmission system losses are low because of low resistance of the high voltage carrying transmission corridors. Now, let us concentrate on, and what about the thickness? When the resistance is lower, resistance is inversely proportional to area of cross section. So, in the transmission system, the resistance is low, that means the area of cross section is very, very, you can see thick lines going over transmission corridors and thin lines, relatively thin, across the distribution systems. Is it clear? And now let us see how different continents or the zones of world experience transmission loss and distribution loss. So, United Kingdom, for an example, experience 1.7% of transmission losses and 5 to 8% of distribution losses. However, in Europe, you could see it is 1 to 4% transmission losses and approximately 2 to 20% of distribution losses. Very, very interesting remarks. The distribution loss can go as high as 20%, my dear friends, and the transmission loss can go as high as 4 to 5%. Is it clear? So, I just like to summarize. The transmission loss will be close to 5% maximum, the distribution loss close to 20% maximum, and the resistance of cables or the conductors for high voltage system is extremely low, and hence the losses for transmission system is lower compared to distribution system. And the X by R ratio is going to be high for transmission system, whereas it is going to be lower for the low voltage network. X by R ratio vary from 1 to 30 for distribution system, from actually 11 kV to 765 kV. Is it okay? So with this, we'll move to concluding our talk now. And once again, thank you very much. So I like to summarize a little bit. So in this case, we focused on transmission system, distribution system, their comparison not only with losses, but also with X by R ratios and their infrastructure, components related to distribution transmission system. And this is a very, very important component. I request all of you to go through the notes during evening hours and make sure you are well prepared when you come for the next lecture. Thank you very much. Bye-bye.